Welcome to the unseen foundation of our modern world. Beneath the surface of every device lies a labyrinth of silicon. I'm here to take you on a journey through the heart of semiconductor technology, where billions of transistors work in perfect harmony. It all begins with a single crystal of silicon, sliced into wafers thinner than a human hair. Using extreme ultraviolet light, we carve patterns so small they are measured in atoms. Modern chips aren't just flat. They are complex 3D skyscrapers of metallic interconnects and insulators. These copper highways carry the data that fuels our global digital economy every second. In an area no larger than your fingernail, we can fit over 50 billion transistors. The goal is simple but difficult: more power, less heat, and incredible energy efficiency. Managing heat is the ultimate challenge at this scale, requiring advanced materials and engineering. Every click, every stream, and every AI calculation happens right here, in the blink of an eye. As we push toward the 2-nanometer frontier, we are redefining what is physically possible. These environments are 10,000 times cleaner than a surgical operating room. The semiconductor industry is a global symphony of logistics, research, and manufacturing. It's an industry worth hundreds of billions, driving the growth of every nation on Earth. AI isn't just a software revolution, it's a hardware revolution happening at the atomic level. Your phone holds more computing power than the systems that sent humans to the moon. From your coffee maker to satellites in orbit, these circuits are the silent conductors of life. Next, we look toward quantum computing, a leap that will change everything we know about data. The pace of innovation is relentless, doubling complexity every 2 years. We are now focusing on making this incredible power sustainable for our planet's future. There is a hidden beauty in these machines, a masterpiece of human ingenuity and art. Thank you for exploring the microscopic heart of our world with me. Stay curious, and I'll see you in the next one. Upgrading tomorrow. Technology for a better future.
Welcome. Today, we explore the incredible precision behind silicon wafer production, the foundation of modern technology. It begins with high-purity silicon, grown into a single, perfect crystal ingot through a meticulously controlled process. These ingots are then sliced into ultra-thin discs, the wafers, measured in micrometers for absolute consistency. Production occurs in a Class 1 clean room, where the air is filtered to be nearly 10,000 times cleaner than the air we breathe. In this sterile world, robotic arms handle every movement to ensure that not a single speck of dust touches the wafer's surface. Chemical-mechanical planarization then polishes the surface to molecular smoothness, creating a perfect base for circuitry. Quality control is paramount. Every wafer is scanned for nanoscale defects that could compromise billions of transistors. Advanced AI-driven systems scan the surface, ensuring that only perfect wafers move forward to the next stage of manufacturing. The result is a masterpiece of human engineering, ready to be transformed into the chips that power our global civilization. At FutureMind, we are dedicated to pushing these boundaries. Thank you for joining us. We are upgrading tomorrow, one wafer at a time. FutureMind International School. Lead the way. Innovation starts here. Subscribe for more technological deep dives. In the heart of modern technology lies a machine so complex, it seems like science fiction. Welcome to the world of advanced lithography. Lithography is the process of printing patterns onto silicon wafers. But as we push the limits of physics, the machines must become extraordinary. Extreme ultraviolet, or EUV, uses light with a wavelength of just 13.5 nanometers. That is nearly invisible, yet incredibly powerful. To guide this light, we use mirrors so smooth that if they were the size of Germany, the highest bump would be less than a millimeter. We are talking about precision at the atomic level. These machines can print features 10,000 times thinner than a human hair. Each machine weighs over 180 tons and requires dozens of shipping containers to transport. It is a marvel of human engineering. Constant monitoring is essential. Thousands of sensors track every movement, ensuring the perfect alignment of every photon. With over 100,000 components and miles of cabling, these are likely the most complex tools ever built by man. The light source itself is a feat. A high-power laser hits a tiny droplet of tin twice, 50,000 times every single second. This precision allows for billions of transistors to be packed onto a single chip, powering the AI revolution and our digital lives. The entire global economy depends on this technology. Without EUV, the progress of mobile devices and cloud computing would stall. The environment must be perfectly clean. A single speck of dust can ruin an entire batch of chips. Precision is everything. As we move towards even smaller nodes, high-end AEUV is the next frontier, promising even greater processing power. Innovation doesn't stop. Engineers are already working on the next generation of machines to break the 2-nanometer barrier. This is a global effort, involving thousands of suppliers and decades of research and development across continents. Every machine undergoes months of rigorous testing. There is zero room for error when you are working at the edge of physics. These machines require massive amounts of energy to operate, pushing the boundaries of sustainable industrial design. The future of manufacturing is here, where data, light, and mechanical precision converge to build the future. Behind the sensors and the steel, it is human ingenuity that drives this progress, solving problems that were once deemed impossible. From tiny atoms to global networks, advanced lithography is the silent engine of our modern world. At FutureMind International School, we are committed to preparing the next generation of innovators for this high-tech landscape. Join us on this journey of discovery. Subscribe for more insights into the technology shaping our tomorrow. Upgrading tomorrow, today. Thank you for watching. In the heart of modern technology, precision is everything. This is where the future is assembled, one microchip at a time. Welcome to the frontier of automated manufacturing. Today, we're diving into the incredible world of high-speed robotic assembly. These machines move with a level of synchronization that defies human capability, operating at scales invisible to the naked eye. Every movement is calculated, every millisecond counts. In this environment, synchronization is the key to efficiency. To give you an idea of the scale, these lines can process over 1,000 individual components every single second. It's a relentless pace that never stops, ensuring the global demand for silicon is met day and night. The tolerance for error here is zero. We are talking about nanometer-level accuracy. Maintaining this level of precision requires an environment 10,000 times cleaner than the air you're breathing right now. In a Class 1 clean room, even a single speck of dust could destroy an entire batch of processes. Flexibility is just as important as speed. These arms can reach any angle in a fraction of a heartbeat. Behind every physical move is an AI mind, performing real-time quality control on every single chip produced. Advanced computer vision systems catch defects that are completely invisible to the human eye. Speed isn't just about the arms, it's about the entire ecosystem working together at peak performance. As we push toward the 2-nanometer frontier, the challenges grow, but so does the sophistication of our tools. We are building cities on a grain of sand, creating the infrastructure for the next generation of AI. It's a rhythm that defines the digital age, constant, precise, and unstoppable. These chips will find their way into every corner of our lives, powering everything from your pocket to the stars. They are the silent engines of our modern world, enabling communication, healthcare, and transportation. From these hubs of innovation, the building blocks of the future are shipped across the globe. And we're doing it more efficiently than ever, reducing waste and energy consumption in the process. Smart systems ensure that every watt is used effectively, balancing power with performance. Final inspection complete, ready to power the devices that will define our tomorrow. The journey of 1,000 miles starts with a single chip. And here, that journey begins every second. Upgrading tomorrow, today. Welcome to the heart of modern industry. This is the AI Control and Monitoring Center, where technology meets precision. In today's fast-paced manufacturing world, staying ahead means seeing everything in real time. AI is the key to that visibility. Our engineers aren't just watching machines, they're orchestrating a symphony of data-driven production. Every second, millions of data points are processed to ensure maximum efficiency and zero downtime. By leveraging advanced AI algorithms, we can predict maintenance needs before a single part begins to wear down. This intelligence flows directly to the factory floor, where automation reaches its full potential. All these systems are interconnected, forming a robust neural network that powers our entire operation. But performance is nothing without security. Our AI protocols ensure that every byte of data is protected around the clock. This isn't just local, we monitor our global footprint from this single, unified command center. Detailed analytics allow us to optimize resource allocation in ways that were once impossible. It's a collaborative effort between human expertise and machine intelligence. The perfect partnership. Information is at our fingertips, allowing for split-second decisions that drive our success. We aren't just preparing for the future, we are building it, one data point at a time. Sustainability is also a priority. Our AI optimizes energy usage to minimize our environmental impact. Since the implementation of AI monitoring, we've reduced our carbon footprint significantly. Precision is the standard. In the AI-driven world, there is no room for error. Even the smallest anomaly is detected instantly, allowing us to maintain the highest quality standards. Every product leaving our facility is a testament to the power of AI-assisted quality control. Our team uses these tools to innovate and solve the challenges of tomorrow, today. Innovation is constant. We are always refining our models to push the boundaries of what's possible. All local data is synced to the cloud, allowing for seamless coordination across our entire network. The monitoring never stops. We are always on, always watching, and always improving. Reliability is our foundation. Our clients trust us because our systems never sleep. Speed and scale are no longer obstacles. They are our competitive advantages. We even use AI to train the next generation of experts in virtual environments. As we scale, our AI scales with us, ensuring that quality remains consistent no matter the volume. From data to delivery, intelligence is woven into every step of our process. Join us as we redefine the future of production, upgrading tomorrow, together. Don't forget to follow our journey into the world of AI. Subscribe for more insights. The future of intelligence starts right here. Welcome to the Monitoring Center. The world is powered by what we can't see. At this very moment, a silent pulse is moving across the globe. Semiconductors. These tiny miracles of engineering are the lifeblood of modern civilization, and their journey is an epic of scale. From the silicon fabs of the East to the assembly lines of the West, the logistics of chips is a race against time. Every second matters. A delay in a single shipment can stall entire industries, from automotive to aerospace. This is the global connectivity theme in action, a network that never sleeps, bridging continents through silicon. The precision required isn't just in the making, it's in the moving. Climate-controlled, vibration-free, and hyper-secure. We're looking at an industry that moves trillions of dollars in value, impacting the cost of everything we touch. Take the automotive sector. Modern vehicles are essentially supercomputers on wheels, and they wait for no one. When demand spikes, the skies fill with the most valuable cargo on Earth. Every flight is a promise kept to the global market. Building resilience into this chain is the great challenge of our decade. Diversification and speed are the new gold standards. Ports around the world are adapting, evolving into hyper-automated hubs to handle the increasing volume of tech components. It's a journey that starts at the microscopic level and ends in the hands of billions. The scale of impact is truly universal. As we move toward 2027 and beyond, the way we ship, track, and integrate these chips will define our progress. AI-driven logistics are already here, optimizing routes and predicting delays before they even happen. From the air to the road, the final mile is just as critical. The journey is continuous, relentless, and essential. Technological stability is geopolitical stability. The flow of chips is now a matter of national security for every major power. Innovation in the lab must be matched by innovation in the field. Every link in the chain must be flawless. We are more connected than ever before, bound together by the very circuits we trade across borders. At EWO Technologies, we understand that behind every shipment is a vision of a smarter, more efficient future. Sustainability in logistics is the next frontier. Greener shipping for a brighter technological tomorrow. It's more than just cargo. It's the movement of ideas, potential, and the future itself. Every chip tells a story of global effort. The pulse is strong, and the journey continues. Together, we are building a world that never stops growing. Upgrading tomorrow. Join us in shaping the digital horizon. Visit our website for more insights into the future of tech. In the heart of our most advanced labs, the future is being forged, one atom at a time. This is where innovation meets reality. Welcome to the frontier of innovation. Today, we step inside the research labs defining the next era of semiconductors. I'm lead researcher, and this is our world. Our environment is designed for precision. Every workstation, every sensor, is tuned to the absolute limit of modern technology. It starts with materials science. We are exploring new substrates that can handle more power with less heat than ever before. Purity is paramount. In our clean rooms, we maintain environments 10,000 times cleaner than the air you breathe. The complexity is staggering. We are manipulating structures so small that even a single speck of dust could ruin months of research. Through advanced photolithography, we etch billions of transistors onto a surface no larger than a fingernail. Robotic precision ensures that every component is placed with sub-micron accuracy, operating at speeds beyond human capability. AI-powered inspection systems monitor every step, identifying imperfections that are invisible to the human eye. By integrating AI directly into our design process, we can simulate and test millions of prototypes in a fraction of the time. Our next general prototypes focus on sustainability, delivering massive computing power while drastically reducing energy consumption. We test our prototypes under extreme conditions, ensuring they can survive the most demanding environments on Earth and beyond. This research is the bridge to the quantum era, unlocking possibilities we've only dreamed of in computing and cryptography. The impact of this work is truly global. We are not just building chips, we are building the foundation of tomorrow's infrastructure. From smart cities to autonomous transport, the innovations from these labs will power the world of 2027. Global collaboration is the key. By sharing our vision, we accelerate the pace of breakthrough discoveries. Every breakthrough here trickles down to the apps, devices, and systems we use every day, making them faster and more secure. Innovation is a journey, not a destination. And here at our research labs, we are just getting started. As we look toward the future, the silicon frontier remains the heart of human progress. Precision, patience, vision. These are the pillars of everything we do. We are upgrading tomorrow, today. Join us in shaping the digital landscape. Upgrading tomorrow. Visit our website to learn more about the future of semiconductor research. In the heart of the digital age, the engines of innovation never sleep. Semiconductor manufacturing is a 24/7 operation, but today, efficiency meets sustainability. Powering the future requires more than just energy. It requires a commitment to our planet. Precision robotics work in harmony with green energy systems to ensure zero downtime production. By integrating renewable sources directly into the production cycle, we've redefined what's possible. Sustainability isn't just a goal, it's the foundation of every chip we create. AI-driven inspection ensures maximum yield, reducing waste and optimizing resources. Every watt is tracked, every process is optimized for maximum environmental impact. Our operations are backed by a diverse portfolio of wind and solar power. Even water is treated as a precious resource, with 95% recycled back into the system. We are setting the global standard for the next generation of industrial manufacturing. These tiny chips power everything from your smartphone to global data centers. They are the heartbeat of the modern world, manufactured with a conscience. Our engineers work tirelessly to ensure that technology serves both humanity and the Earth. From raw materials to finished products, our supply chain is optimized for the future. A smart grid management system ensures no energy goes to waste, day or night. Our goal is clear: zero carbon emissions across our entire global footprint by 2030. We are researching new materials that will make tomorrow's chips even more efficient. The world depends on the innovation that happens within these walls. What we achieve here can be scaled across every industry on the planet. Innovation happens at the smallest scales, with the biggest impacts. Every etch is a step toward a more connected and sustainable world. We believe that growth and sustainability must walk hand in hand. Closing the loop means recycling the technology of today to build the chips of tomorrow. Large-scale energy storage ensures our production lines are always active, regardless of the sun. Join us as we lead the charge into a sustainable, high-tech future. A new dawn is rising for manufacturing, one that is cleaner, smarter, and faster. Upgrading tomorrow, leading the way in sustainable semiconductor technology. Subscribe to follow our journey toward a greener future. Visit our website to learn more about our 24/7 sustainable operations.